Have you ever wondered why some websites just pop up instantly while others feel like they take forever to load? Well, today we're going to pull back the curtain on the invisible superhighways of the internet that make all the difference.
We've all been there, right? Staring at that loading spinner, just waiting. It's a feeling we all know. But here's the thing. What's happening behind the scenes isn't magic. It's actually physics. And the solution to it is just incredibly clever.
Okay, let's break this down with a really simple example. Let's say you're in Sydney, Australia, and you want to visit a website, but the computer, the server that holds that website, is all the way in New York. That is a long trip for data to make. Now, what if you could get that same website from a server that was right there in Sydney with you? Well, that's the big idea we're going to unpack.
So the real villain in our story is just distance. In the tech world, we have a name for the delay this causes: latency. It's basically the travel time for your request to zip over to a server and for that server's response to zip all the way back to you.
And I do mean literally. The internet isn't some magical cloud. Nope. It's a very real, very physical network of wires and fiber optic cables that are stretched under oceans and across entire continents. So that request from Sydney to New York, it's physically crossing the Pacific Ocean. No wonder it takes a second. So how in the world do we fight this tyranny of distance? I mean, we can't break the speed of light, right? So instead, we have to get smarter. And that's where the hero of our story comes in, the Content Delivery Network, or CDN for short.
Okay, so what is a CDN? Well, the official definition is a geographically distributed group of servers that work together to get you internet content fast. In simple terms, it's a whole team of servers strategically placed all over the world with one job: get websites to you as fast as humanly possible.
Now, here's the really clever part. A CDN doesn't make data move faster through the cables. What it does is so much simpler and honestly kind of brilliant. It just makes the journey shorter. It's the classic work smarter, not harder approach.
And the secret weapon in this whole strategy is something called an edge server. It sounds technical, but it's really just a CDN server that's located geographically close to you. So in our example, that server in Sydney, that's the edge server for our user in Australia.
So let's picture that journey again. Without a CDN, every single user, it doesn't matter if you're in London, Tokyo, or Sydney, everybody has to make that long, slow trip back to that one main server in New York. It's a huge traffic jam, super inefficient.
But with a CDN, this is where it gets good. The CDN makes a copy, a cache, of the website's content on all its edge servers around the world. So when you, in Sydney, go to the site, you're not fetching it from New York anymore. You're just grabbing a local copy from a server that's practically your next-door neighbor.
But speed is only part of the story. A CDN also acts like a bodyguard for the main origin server. It steps in and handles all the requests for the static stuff, things that don't change, like images, fonts, logos. This frees up the main server to focus on the really important dynamic stuff that's unique to you, like actually processing your login or handling your shopping cart.
So, all this clever work, this whole system, leads to 3 huge wins. And these are wins for both the person who owns the website and for you, the user.
First up, the most obvious win, and it's a big one. This is the direct counterattack to that whole distance problem we've been talking about. By bringing the content closer to you, latency just gets crushed. The website feels snappy. It feels responsive. It just works better. And for any business, this is massive. A faster site means happier customers who actually stick around.
The second big win goes right back to that bodyguard analogy. It's not just about getting data to you faster, it's also about taking a ton of pressure off the main server. And you can really see the benefit here. The main server isn't getting bogged down trying to send out thousands of the same image file. It can actually dedicate all its power to its most important jobs, which makes the whole website run smoother for everybody. And finally, our third major benefit. This one is all about reliability and being able to handle the unexpected. Like what happens when a website suddenly goes viral? A single server can get overwhelmed by a sudden flood of traffic and just crash. But a CDN is an army of servers. It just distributes that huge load across its network, easily handling traffic spikes that would normally take a site completely offline. That means more uptime and a way more stable experience. Now, this might all sound like really complex, high-end technology, but one of the best things about CDNs is how surprisingly easy they can be to get up and running.
For a lot of websites, it really just boils down to two core steps. First, you upload your static files, your images, your code, onto the CDN service. Then you just update your website's code to point to the new location of those files. It's kind of like changing the shipping address so a package gets sent from a local warehouse instead of from halfway across the world.
All right, let's do a quick recap. The #1 enemy of a fast website is physical distance. CDNs beat that distance by storing local copies of content on edge servers right near you. The result? Websites that are way faster and way more reliable. Plus, a CDN acts like a shield, protecting your main server from getting totally overwhelmed.
So that leaves us with this final thought. A CDN is, at its heart, a brilliant shortcut. It proves that sometimes the biggest leap forward isn't about more raw power, but about finding a shorter, smarter path. It really makes you wonder, doesn't it? What other invisible systems that we use every day are just waiting for that same kind of thinking?